Mistaken. We are going to very much continue on converting moles to mass, and mass to moles, and particles to mass, and particles to moles, and we're going to do moles to moles today. We're going to do all sorts of fun stuff.
That doesn't even sound right.
Yep. Getting there. So, stoichiometry. Now we're getting into it. We've been building up to the greatness that is stoichiometry, guys. And now we're here. But we're still going to take baby steps. A little bit out of time. So, what stoichiometry is the mathematical relationship between the amounts of reactants and products in a chemical reaction. And who knew that chemistry math was very similar to recipe math?
Well, that would make sense.
Okay? Did you guys know that the coefficients in a balanced chemical equation are the recipe for the equation? Mind blown. So let's use a recipe analogy to help bring this home. Let's say you're going to a party.
You gotta make guacamole.
Alright, and you decide to bring some Rice Krispie treats.
No!
Yep, age old, and maybe a little old. So you want to make some Rice Krispie treats. So you have to first what? Probably
Go buy Rice Krispies.
go what?
Buy Rice Krispies.
Well, how do you know how many Rice Krispies you need?
Look at the recipe.
You gotta first look at the
Recipe.
So you go into your little handy-dandy cupboard, and right, you probably don't have any recipe sheets anymore. You just millennials
Look
just
it up.
Google it. Okay.
Okay, Kramer, you're a millennial. We're not even millennials.
I know I am a millennial.
We aren't.
Yeah, you're a generation loser.
Us
Okay,
are.
No, I think we're like.
We got records.
I think we're the I generation, actually. I think
No, that's like.
Sorry, that was inappropriate.
No, it's okay. We're the generation that's not supposed to outlive our parents. So.
Okay,
Not supposed to live out our parents.
okay. Let's get back. Let's have the maturity level. Get back on track
Alright,
here.
Rice Krispie treat.
24 Rice Krispies.
Okay, so this is how many. Shush your mouth up. You go in and you find that you need. How do you?
Three tables.
How do you? I'm not. I can't. How do you abbreviate tablespoons?
TBS. TBS. No. It's either
Table. S is teaspoons.
tablespoons.
Yes.
TBS.
No, TPS.
Yeah, there you go.
That's not right. How do you know that's
No,
not
that's
right?
teaspoon.
Let's Google it. No.
It's TBLS. I
No,
guarantee.
it's TBS.
Look it up.
I bet you $10.
Oh,
Yeah, that's how I
wow.
say it.
I have a thing at home that says TBLS. I don't like
It's lying.
TBSP. So we're all wrong.
Oh, I said that.
Yes,
Got
I just said that.
Okay, I knew there was a fourth letter, okay?
Alright.
TBLS.
That's
But if
hilarious.
it's plural, then you put another S?
No.
To
Ignore it. It's tabasco, okay?
Okay, 3 tablespoons of butter is what it calls for.
teaspoon is TSP.
Little, little bit of
Marshmallow.
I gotta think about it.
Rice Krispie treat.
And then you need 6 cups of what?
Sugar.
Water.
Sugar.
Rice Krispies.
Corn
Why are
syrup.
we adding more sugar to this?
Yeah. There's really not any needed sugar. You got marshmallows, you got
Yeah,
cereal.
that's disgusting.
Okay.
Butter.
Oh, vodka.
Now, would you agree with this statement? Listen very carefully. If you were hungry, you could scale up the recipe to make more Rice Krispie treats.
No.
Yes.
Yeah.
If you were like a typical millennial, like myself, and you were worried about your weight, could you scale down the recipe?
Yeah.
Good. You could. Okay? But the only way to do that, or the only way you could scale up or scale down and make it work, would be you'd have to preserve what?
The proportion.
The proportions, the ratio. Yes.
Yes.
Okay? So suppose you go into your cupboard and you go, uh-oh, I only have 4.5 cups of cereal.
Cups.
Such a hater, what the heck?
So if I had an answer that was cups on the test and I put cup,
I would not put that answer.
oh darn,
What do we do?
what do we do?
Just gotta tell
So
them.
I just throw 40 marshmallows and 3 tablespoons of butter and you get a real mushy Rice Krispie treat, right?
Just
Find out the
make 3
ratio.
cups so you can have the recipe.
Make a proportion.
Yeah.
I gotta make a proportion. Hey, doesn't this look like something we've been doing quite a bit?
Kind of.
Guys, we know that 6 cups go with how many marshmallows?
40. I think.
And if I did that, you would find that you need 30 marshes.
Or
Okay?
30
Could I do this for butter? Could I do this for how much treats I can make? Yes or no?
Yes, sure.
Yes, you absolutely can. Okay? Now, similarly, chemical equations show the ratios of substances involved in the reaction with their coefficients. Did I do something wrong?
Yes.
Aren't you canceling out cups? What did you multiply? March. 4.5 times 40.
You divide it
Divide
by
by
6 and then you multiply it by.
Anything on top, you multiply, anything on bottom, you divide?
So it's 4.5 divided by 6 times 40.
Or 4.4 times 40 divided by 6.
Oh, okay.
Or we're
I was
just divided by
thinking
6
one,
times 4.5.
like you just did 4.5.
40 times 6 divided by 6.
So essentially that's 3/4 of 6. So this should be 3/4 of 40. Probably done that up. Okay? So let's say
That's 9.
that I have this equation. P4 plus 502 gotta produce 2P2O5. Okay? Let's say you go into your theoretical chemical supply room and you realize that you only have 2.5 moles of oxygen gas.
Ah, dang.
Wow.
Does that mean that you're up a creek?
Yes,
Yeah.
it does.
No.
But you have paddle.
Yeah, we do have a paddle. It's called changing the recipe, or modifying the ratios, I should say. Okay, so what I'm trying to say here is just like a recipe can be modified, so can the recipe of a balanced chemical equation. What I mean by that is, that doesn't mean I'm going to change these numbers, but if I don't have the exact amount, I can scale it down or scale it up proportionally. Okay? Which, believe it or not, if you have a balanced chemical equation, couldn't you then figure out exactly how much product you could produce from a certain mass of substances you have? Oh. Cool. Let's
Cool.
do it. So, what a mole ratio is just what you would get from your recipe. So you're going to hear me say recipe of a chemical equation. What I'm referring to when I talk about the recipe are the coefficients in the balanced chemical equation. That is how we maintain our kosher recipe. Okay? Nice big word. Okay? So if I were to say, what is the mole ratio between P4 and O2, what would you say? P4 and O2?
Wait, what?
What is the mole ratio between P4 and O2? 1 to 2. 5.
Yeah.
Huh?
What?
1
Oh!
to 5. What did I say was the recipe?
Oh,
I
got
thought
it.
you were
Oh, it's already
P4
balanced.
already.
Okay. Well, now that you are on my wavelength, what would be the recipe or the ratio between P4 and P2O5?
1.5.
Wait,
Wait,
2.
two.
1 to 2.
I'm sorry, I wasn't looking and I just,
Okay.
I thought you said 5.
So, if I had 2.9, you could probably do this in your head, but if I had 2.5 moles of O2, how much P4 would I need to react with that?
Half.
And yes, it ends up being a half, but I can use the mole ratio. I need to cancel out moles of O2, correct?
Yep.
And I'm wanting to find
Follow
moles
on.
of P4,
Ow.
and the ratio is a 1 to 5.
5 underneath 1.
So based on the recipe, if I know I need 5 oxygens for every 1 P4, if I have 2.5 oxygens, I would need to scale down how much P4 can react with it and do it proportionally. Make sense? So, let's do this problem. I'm going to show you where we are on our cheat sheet, just for all intensive purposes, because we're going to begin going to the other side. So I believe we had, mass, and then we had moles, and then we had particles. But then we had a whole other side.
But the other side is the same.
It is. Okay, so here's the difference here. Up to this point, we've just kind of stood and hung out over here. And this was the given side, and this is the desired side. So everything we did desires. Okay. Desire. So everything we've done up to this point has been staying within one substance. Like everything in our worksheets, we said how much mass is 2.5 moles of this one substance. We never talked about any other substances in the problems, correct? Read what this says. Suppose a chemical engineer wanted to produce 25 moles of diphosphorus pentoxide, which is this equation that I had up here earlier. Okay? How many moles of phosphorus would you need to do that? And how many moles of oxygen would you need to do that? Because obviously, we're not just producing 2. We want to produce how many? 25. But we have to maintain the same ratio. We're just going to scale it up. Make sense? So really what we're doing is we're converting from mole to mole. But notice, different stuff. You see it? So, we are starting with what we've been given. Write that down. You should be following along here with me. So where would we be up here? Where on this chart?
There's a mole.
But there are 2 moles up there.
Given
We are here. Where are we going?
to the desired mole.
To the desired moles. How many steps is that?
1.
We'll do the first part here. Moles of phosphorus, or P4. Now, if you look at your cheat sheet, underneath the mole to mole arrow, it says coefficient bridge, from the balanced chemical equation. This would also, you could also modify that and say it's from the recipe. Okay, and what is the recipe of the balanced chemical equation? What is it? No, what tells us the recipe? The coefficients. Okay? Now, we need to get rid of moles of P2O5 and get moles of P4. So just like everything we've been doing, all the way back to chapter 3, unit cancellation's king here. I've seen a lot of deer in the headlights gaze. Either I've lost you or I've bored you, one of the two. Okay? This right now is very easy, but we're going to be getting from here to here. Here to here.
I don't like that.
Okay, so focus, because you can't get there unless there's only one way to get there, and how is it?
Train.
The mole train. You gotta know what we're doing today to be able to do any of that stuff in the future. So focus for me. Canceling out here. And where are we going?
Moles.
And do you see why we call it the mole ratio?
No, why?
Yes.
Because it's a ratio of moles. Who
Whoa.
would have thought? Okay, now where do I get these numbers?
That's a good question.
From the, I heard it, the recipe. And what's the recipe? The coefficients in the balanced chemical equation. So, here is 1, here is,
Two.
and our answer is?
Something.
Wait, oh, 1 and,
Right?
oh, duh.
If I know the ratio is a 1-to-2 ratio, and I have 25 moles of P2O5, I'm going to need 12.5 moles of P4 to get there. Yes?
So the coefficients are like if they were in parentheses, then they'd be like that number before. What do you mean parentheses? Because there was a coefficient before that. Oh,
There's a what?
like a 5.
Yes. We're going to solve for that in this part. This just tells me how many P4 I need. We're about to solve how many O2 I need. And it's going to be 4. Okay? So we could actually start with this and figure it out. But let's start with what we've been given again. But now, instead of going to P4, we're going to O2. So the ratio is different, isn't it?
Yes.
And where am I looking to find these numbers? Mr. Gage,
Why was
are you all right?
Yeah.
What's the matter?
Wasn't on my Gatorade.
What do we get? What's the numbers?
5/2, 5.
Anybody not know where I'm getting those numbers?
Wait, why?
No, it's 5/2.
5/2. You're right. Just checking to see if you're paying attention.
Getting it from the equation.
Okay. 25 times 5 divided by 2.
62.5.
Did you do that in your head?
I did.
Okay. Now let me explain what this means. Okay. All I said was I want to produce this much product, and I discovered exactly how much moles of each I need to get that. Could I convert these to mass and figure out how much mass I would need to do the same thing? Isn't that what we did the first part of the chapter? Can I take this and multiply by molar masses?
Yeah.
That's where we're going. Why don't you guys give this here problem a try?
This here problem. Holy moly.
React.
That's funny.
Don't make a mole.
That was a good one.
Make it quick, guys, because the next problem we're going to write the equation, balance the equation, and then do the stoichiometry. So, let's go. Huh? Seen a lot of people just not doing anything. I don't want to name names, but
Expensive.
Let's keep going.
some of you could probably do this in your head, but get in the habit of writing it out. You really just need to go print out the notes there, girl. If you can figure out the ratio, you can figure out the answer. So, anybody got an answer yet? What'd you get, brother?
37.5.
No. Gage.
75.
75.
Oh, what? Oh.
25 times 3.
Well,
Well, but I wanna do the work to figure it out, not
Okay, and I'll show you the word.
Okay, yeah,
What?
that's cool.
So what do we start with?
We're starting with 25.
Moles of what?
Well, diphosphorus pentoxide.
Which is P2O5. Okay, and we're going from moles of P2O5 to moles of water. Okay, so that would be a mole to mole step, which is our mole ratio. One step. Okay, you always got to cancel out what you have.
Nice.
So moles of what goes on bottom,
One mole.
P2O5.
and what you're going to is always going to go on top. What is it?
Mole of H2O.
Good job, Tanner. And then you just look up at where the numbers come from and plug them in there.
3 and what?
3 goes with that, because I got 3 H2Os. 1 goes with that, and that's where 25 times 3 gets to 75. What'd you do, brother?
I use the
long ratio.
Yeah, I did the 2H3PO4.
You thought that was, so you had 3 over 2.
Instead of actually reading and thinking.
It's okay. Only homeschoolers are good at that.
Now you're
Reading and thinking.
I disagree with
Actually, I shouldn't say that. There's some notes I'm homeschooling.
Hey, man.
I was a homeschooler, so.
Maddie, you lift
You know
your
how much
sword
Gatorade-
so high
Stop
on your
it.
feet.
Gage, stop it!
Can't say
Hey, you ready to do? Hey, guess what? Guess what? Hey, guess what?
What?
Did you know? Did you guys
I'm
know?
not writing that.
Newsflash.
What?
Maddie's smart.
Stop it.
Newsflash.
What?
Chemistry builds on itself.
No way.
So, we gotta first write the equation, then we gotta balance the equation, then we gotta do the stoichiometry of the equation.
What's
Do you
that?
think if you write the equation wrong, you're gonna balance the equation wrong?
No.
You think if you balance the equation wrong, you think you're gonna get the wrong stoichiometry amounts?
Yes.
Sweet.
So innocent.
Let's do it.
Put this as my favorite class.
Yeah, me too. What? And my favorite teacher, you.
You, yeah. Okay.
Well, I don't think I answered that one.
Really?
I didn't
The
either.
teacher or the class?
Oh,
I didn't even do
What are you
it.
talking about?
Teacher.
JoJo gave us
a survey thing
for the yearbook.
Ah,
For favorite
What?
teacher?
Yep.
I'll call her. What
I know who's winning now.
Uh,
I can call it.
It's you,
Let's
actually.
go.
I can call it.
No, that's
you.
No, I can call it.
Who do you
He's
think?
not said it.
Miss Stoker.
Wow, fish.
Stoker? What?
None of you said it yet. Fish.
Senora.
No.
It's you.
Nihilist.
Yes.
No, he's not. It's you.
Absolutely. Guarantee. I'll call it right now.
No, it's you. I'll call him.
You want to know why? I'm not gonna say.
Bet it's you.
No,
Why?
Why? Why?
Because you know it's easy.
No.
What?
He has more students than like anybody.
He's really enjoyable and it's easy.
No,
He has to deal with like 85 kids.
Kramer, there's so many.
I'll call it.
Kramer.
This is not.
Kramer. Bet. No. Bet.
Every
How
class.
much?
$10.
Yeah,
I don't think so.
Hey,
I don't have any money, but I would bet $10.
Gambling is against
For
the
real.
Bible.
It's not nice because a bunch of kids think
Gambling is against the Bible. I will bet you a Bible. Everyone
Be unwise and now your money
You're
is
so
against
grumpy
the
right
Bible.
Hey,
But if you know you're gonna win a bet, it's
I'm pretty confident now. I'm almost confident to bet, but I'm not easy. Okay.
What if you gamble for Bibles?
So gambling. I'm not giving away my Bible. What else is nice?
All right. Why is it nice? Because you don't use it? No, it's leather. It's so nice.
Yeah.
Oh,
Man,
show
That-
you.
you're no longer
Oh, dude, I'm trying to make my status go down so that the house's status can go.
Oh
Is that on
no.
camera, Mr. Kramer?
What?
Oh, yes it is.
Oh,
What?
Is that on
yes it
camera?
is.
Yeah, definitely.
I like real.
It's not true, so it's only funny because it's not true.
Oh.
Alright, let's begin this. One disadvantage of burning propane is that carbon dioxide is one of the products. So again, reading is important in doing this. Okay? That first part told us one reactant and one product, didn't it?
Yes.
What's my product? What's one of my products?
Well,
Okay? And one of my reactants is
C3H8.
Okay? The release of carbon dioxide increases the growing concentration of CO2 in the atmosphere. How many moles of carbon dioxide are produced when 10 moles of propane are burned in excess oxygen gas? What?
O2 plus O2.
Is it a reactant or a product?
Reactant.
Anytime you're burning something, what do you need?
Oxygen. Well, fire.
Amen.
Right? Now, you might not know this, but a byproduct of this is always going to be. Now, if I was giving you this on a test, I would have given you enough information for you to figure that out. But, okay? Now, let's balance it. You want to try to do that visually or just quickly? What do you think?
Let's do it visually.
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 Okay?
So you're gonna.
Shade, shut up.
So let's start with carbons because it's the best way to do it.
No, just look at it. Look at that.
That's what I'm doing. Looking at it. 3 and 1 make it 3. Yeah?
Yeah.
Okay?
Then you're gonna get
Let's
6
do hydrogens. That's the next easy one to balance. I got
4.
8 and 2. 8 and 2, 4.
Yep.
Now we're gonna have to think about the
What
oxygen.
two before the oxygen on this
We
side?
got 6
5.
and 4 is 10.
So far.
So 5. Everything should be balanced. We're good.
5, 3, 4. Okay.
Wow. Burning it.
Make a T-chart by all means. That's probably what I. Easy.
Actually.
Easy. Only one person can roast people in here. Okay.
Only one gross.
Or
And you need
1 to
oxygen
3.
for it.
Amen. Okay. Now let's identify what we're solving for here. Markings.
All this stuff.
Gauge.
Stuff for fun.
I told him the answer.
What's the starting point?
1.
No. What have I been
10.
given?
10 moles.
Propane, which is, listen guys, focus.
C3H8.
Okay. What am I solving for?
However many moles of carbon dioxide.
Moles of carbon dioxide. And you're going to find out later that this word excess is very important.
Great.
Nice, man.
Because what that's telling us is this is our limiting reactant. And that's the hardest part of this chapter. We'll get to that at the end of this chapter. Okay? So, since it's a mole to mole step, we know it's our one-step problem. Moles of what goes on bottom?
CO2.
It's really important now
Oh,
that you
right, cross
do.
cancel.
It's really important now that you actually show not only your unit but your substance, because from here on out we're going across the bridge every time. Okay? And when you cross the bridge, you're changing what?
Units.
Substances. We're going from our given to our desired, and that's important. Because if once we get to doing mass, if you don't change the substance, you're going to use the old mass instead of what you should be using. Okay? And what did this say we were solving for? Moles of?
Carbon dioxide.
And then we look at the recipe and we see that it is a what to what ratio?
300.
What? No. Nice try.
Which should give us our 30 moles of CO2.
Bell rang.
Well, you were right.
Okay? So what we discovered was exactly how much product, one of our products, we could have solved for the other product too, that are going to get produced if I have 10 moles of propane and excess